All right, guys, we're going to go ahead and start today, Monday, with a new lesson. Um, so we're starting off with the first section, just kind of talking about some random things as far as like basic geometric terms. So undefined terms is one of those areas where we're talking about a point and a line. A point and a line don't actually exist. They're just merely locations themselves. But if I kind of move to the line here, this is an important part of it because I want to be able to label this line several different ways. If I'm talking about just the segment of the line itself, since a line only requires 2 points to create, I'm going to write this line as line segment PQ. All right. If I want to show that the line actually goes through the arrows themselves, an infinite line, then I'm going to represent this as the infinite line PQ that goes through the points P and Q. And then you notice over here you have this little m, lowercase m by itself in italics. You can also label this as line m. You'll see it presented different ways. The same thing with a plane. A plane, you only need 3 points to create a plane, but those 3 points cannot be on the same line. So when we're looking at this, again, we can label this as plane, any combination of those letters, BCD, CDB, DCB, any one of those combinations is fine, or off to the side, you see this capital K in italics that you could write this as plane K as well. So when we kind of go through, collinear points, points that lie on the same line, coplanar points, points that lie on the same plane. Okay? So if I'm looking at an example and I want to use this figure name a line that contains the point K, well, a line that contains this point K, we can write this as line JL. We can write this as line KL. We can write this as line JK, or you can write it as line A. If I want to describe a plane that contains the point L, we can use any 3 non-collinear points. So I can't use J, K, and L, but I can use 2 of these points and M. So I could say plane JKM. You could say KLM. You could say any one of those combinations, or you could say plane B. This B over to the side here in the corner represents the entire plane itself. How many planes are in this picture? We have 2. This is one of the planes, and this is a plane. Recognize that these dotted lines right here represent these 2 lines that are actually going through the plane itself. You're taking a 3-dimensional picture and you're putting it on a 2-dimensional surface. So you have to represent these as being under that plane, and they come out right here. 3 points that are collinear on the same line, A, B, D. And then are these points, A, B, C, and D, coplanar? No, they're not. A, B, and C are on the same plane, but D off by itself over here is not coplanar. What point do DB and CA intersect? All right, so DB is this line right here. CA is this line right here. We can see that as these lines intersect, they intersect at the point A. Now, that brings up a side note. 2 lines intersect at a point. 2 planes intersect at a line. All right, so between, the idea of something being between is that I know that M is between P and Q only if PM plus MQ is equal to PQ. Okay? And it basically means, look, if you have these 2 points or 3 points, A, B, and C. How do I know that B is between A and C? Well, if this is 2 and this is 3, then AC is equal to 5. That's all that is. Okay? So we'll kind of abbreviate some of the things here when we're talking about LN. LN is the whole line. So if I want to find out what LM, I'll subtract the whole thing from the parts and then get 1.4. And then we can introduce some algebra to this as well. So finding the value of x and st if t is between s and u. So t is between s and u. St is 7x. Su is 45. And tu is 5x minus 3. Well, then we take the parts. If t is between u and s, then ut plus ts is us. So 5x minus 3 plus 7x is going to equal 45. Combine like terms. Add this 3 to both sides. 12x equals 48. And so therefore, x equals 4. Find the value of n and wx if w, I'm sorry, I'm going to go back here for a second. Since x is 4 and we were asked to find what the value of st is, if st is 7x, 7 times 4 is 28. Find the value of n and wx if w is between x and y. So let's draw a line, x, y, w. W is between x and y. Wx is 6n minus 10. Xy is 17. And wy is 3n. So we would take 6n minus 10 plus 3n is going to equal 17. Solve for n, plug it back in. So distance is always positive. That's how I take the absolute value of it. So suppose that point E has a coordinate of -2 and EG is 8. What are the possible coordinates of G? Well, if this is E, then if I count 1, 2, 3, 4, 5, 6, 7, 8, I could put G over here. That's 8 units away. Or I could come back this way. 1, 2, 3, 4, 5, 6, 7, 8. And G could be here as well. So therefore, my two possible values are -10 and +6, because they both have a distance of 8, forming the distance of the line GE as 8. So if we're talking about angles, when we have an angle, we form two rays. This is a ray, it has an endpoint, infinitely going in this direction, and a ray that goes here, starting at this point, going another direction. A line is two opposite rays. So if I have a point here, and I create this ray, and from that same point, I go the opposite direction, I have just created a line. Okay, so point Y is on the interior of angle XYZ. Given that WX and WZ, we'll say WX and WZ are two opposite rays, the measure of XWY, if I can put Y anywhere in there, is 4 times the measure of WYZ. So let's just kind of create this line here for a second. Okay? So this measure right here, XWY, is 4 times the measure of whatever this is. So let's call this X, and we'll call this 4X. Now the measure of the angle of a line, if I add up these two angles, this angle and this angle, they're going to equal 180 degrees. I want to find out what the measure or the value of x is for x plus x. All right, so we have 5x equals 180. Sorry, the pen's not keeping up here. So x is going to equal 16. All right, so again, an angle is formed by two non-collinear rays, so this angle right here and this angle right here. We can have the interior and exterior of the angles. This is my angle. These 2 points are on the interior. These 2 points are on the exterior. The values of the angles themselves, we can have a 90-degree angle, an acute angle, or an obtuse angle. Right angle, 90 degrees, an acute angle less than 90 degrees, and an obtuse angle anywhere between 90 and 180 degrees. Congruent angles, the sign congruent is this. It means it's equal and the same. So if I have an angle bisector, this line right here is an angle bisector, meaning that it splits the larger angle up into two congruent parts. We recognize those by drawing arcs. So I could say this angle right here is congruent to this angle right here. I could say that this angle right here is congruent to this angle right here. We represent congruent angles in a picture using the arcs like this. Now, your homework for this particular section is going to be found off of your backpack. So if you go into your backpack, I'm going to click into your backpack, go into Education Apps. You're going to scroll down to this Pearson Easy Bridge. Sign in, and you're going to see your class. If you open this up, it opens up the book itself, Envision Custom Geometry. It's probably been a long day so far. Go to your classes, and you'll see that you have an assignment here. Click on the assignments, and this is what you'll be working on. Again, due Friday. Okie doke. Hope you guys have had a great Monday so far and look forward to seeing you in class.